Bonjour. This is the second video for Système d'équation du premier degré, and yes, in the previous video we looked at the methods of solving it, elimination and then comparaison, both of which are best used for two equations with two unknowns. Once you go more than that, then it becomes a little tricky. So today we'll learn a method called substitution, which can be applied for even for a set of equations which are more than two equations. So three equations with three unknowns, or four equations with four unknowns. Okay, so we'll take the same example that we took earlier. 3x plus 7y is equal to 20, and the second equation is 4x plus 3y is equal to 40. So that is what I have here. So the first step is you take one of the equations. In this case we will take equation 1, and you find out x from it. So this is what we had done here also. We had par 1, on a pris 3x plus 7y est égal à 20, on a écrit x est égal à 20 moins 7y sur 3. So this step is exactly the same here. So par 1, so I copy again just to make sure that I know what I'm doing. This is important. I could have gone straight to this point, then you would get a little confused if you saw it after a few days. So best is to copy it, and then you find out x est égal à 20 moins 7y divisé par 3. 20 moins 7y, when x 7y goes that side, it becomes negative. And then you have 3x is equal to 20 minus 7y. So x is equal to 20 minus 7y over 3. Now of course the method diverges. So now the method says that you substitute in the second equation and any other equation that there might be. Suppose there were three equations with three unknowns. Then you substitute in the second and third equations this value of x. So here we only have only one equation. So we will substitute this value of x in this equation. So let's do that. Remplaçant ou substituant, that's where the name comes from, substitution. 3 into 2. So we put 3 into 2. Remember, we got it from 1, so if we put it back in 1, it means nothing. We'll come back to the same thing. And we put it in 2. So 2 again, I copy it. First, 4x plus 3y is equal to 40. See, this step is important to copy it. I don't want to keep on looking up and down when I see this and then I have to look up. No, I write here and then I replace x with this value, 20 minus 7y over 3. So 20 minus 7y over 3 plus 3y is equal to 40 plus 3y is equal to 40. So what I do is the simplest is I multiply everything by 3 to get rid of the 3 in the denominator there. 4 into 20 is 80, 4 into minus 7y is minus 28y, and 3 into 3 is 9y, 40 into 3 is 120. So this gives us minus 19y is equal to 40. So what have we done here? Essentially what we have done is we started with two equations and two unknowns, and we have ended up with one equation and one unknown. So this we can solve very easily. Y is equal to minus 40 over 19, which if you remember is what we got when we did it through comparison also. Y is equal to minus 40 into 19. Now that you have this, you can say remplaça 4 3. 3 is this one where x is already defined in terms of as a function of y. So you put in there. So x is 20 minus 7 y minus 7y, 7y is all of this, so minus 7 into minus 40 over 19 divided by 3. If you do this, it's actually the same as what we have here. You will come to x is equal to 660 over 57. So we have now used the method of substitution to get the same result as we got here, which actually went on to the top of the next page, and as we got here in the previous page through elimination. So Now that we know that we have learnt all three methods, just to recap, in elimination you multiply both the equations with the number so that one of these values gets eliminated. That's why it's called elimination. Here we multiplied the top by 4, the top equation by 4, the bottom equation by minus 3. So we got 12x minus 12x. When you added it, only this part was left. 19y is equal to minus 40. In comparison, we took both equations and we found out x in terms of y, x as a function of y from both equations. So first one gave us this, the second one gave us this. Since this is equal to x and this is equal to x, that means this is equal to this, which is what we did, and then we solved for y, and then we put it back into any one of these equations and you will get the result. Okay, so now let's take substitution with three unknowns, three equations and three unknowns. Ok, substitution, exemple avec trois équations et trois inconnus. So here I have three equations, I number them 1, 2, 3, and I have three unknowns, x, y, and z, x, y and z. So the first equation is x plus y plus z is equal to 10. Second equation is 2x plus 3y plus 6z is equal to 43. Third equation is 3x plus y minus z is equal to 4. So how would we solve this? So similar to what we did on the previous page, we take any one equation. Here we'll take equation number 1, but you could take 2 or 3. It's simpler because there are no coefficients. These numbers are 1x plus 1y plus 1z, so I prefer to take this. Let's find out x in terms of y and z from 1. So you can write par 1 x est égal à 10 moins y moins z. Actually I should have copied 1 here and then done it in the next step, but I was lazy and you shouldn't be. So here, so x is equal to 10 minus y minus z from equation number 1 par 1. Now what we do is we put this value of x into the other two equations. In the previous example I put it only in one equation because there were two equations and two unknowns, but in this case I put it into equations 2 and 3. So let's take equation 2 first. Remplaçant 4 2 et 3. This one we're going to put in 2 and 3. So you see on here I've copied it, 2x plus 3y plus 6z est égal à 43. So let's put this in, replace x with this value, this expression. Therefore these moins y moins z plus 3y plus 6z est égal à 43. We simplify this, 20 minus 2y minus 2z plus 3y plus 6z is equal to 43. This gives us y plus 4z is equal to 23. That 20, when it goes that side, it becomes minus 43 minus 20 is 23. And here minus 2y plus 3y gives you y, minus 2z plus 6z gives you 4z. So equation 2 now turns into this equation, which we will call equation 5. Remember, we have to replace it also in equation 3. So let's do that. 3 into 3, by into I mean replacing into equation 3, not multiplying by 3. You copy that again. 3x plus y moins z est égal à 4. 3x plus y moins z est égal à 4. And you put in 3, you put in the expression of x which you got here, equation 4, plus y moins z est égal à 4, and then when you simplify it, you get moins de y moins 4z est égal à moins 26. You can change this, you can multiply the left side and right side by minus 1. So you will get y plus 2z is equal to 13. So you have equation 5 and 6. Equation 2 turned into equation 5. Remember, now you can see that there is no x there. Similarly, equation 3 turned into equation 6, and again there is no x in that equation. So I will rewrite it, I will copy equation 5 and 6 again, just one on top of another, And what do you see? Maintenant, on a deux équations avec deux inconnus. So we started the problem with 3 equations and 3 unknowns, and by substituting one of them, we removed it and we now ended up with 2 equations and 2 unknowns. And we know how to solve this because we have, this is what we did here. We started with 2 equations and 2 unknowns and we did it. So systematically, if we had 4 equations with 4 unknowns, you would end up with 3 equations, 3 unknowns, then 2 equations, 2 unknowns, then 1 equation, 1 unknown. And when you would solve for that one unknown, you would work backward and you would get all the unknowns. So let's see. So now we have 2 equations and 2 unknowns. So again we take the value of one of these from one of these equations. When I say value of one of the inconnue, so we'll take y because it's simple here. So I can write from 5 par 5, y est égal à 23 moins 4z. 23 moins 4z. Now that we insert into equation 6, remplaçant en 6, y plus 2z est égal à 13. Now we know y est égal à this, so we put in, instead of y, we put 23 moins 4z plus 2z est égal à 13. When you do this, you get moins 2z est égal à moins 10, donc z est égal à 8. I write it on the side because I run out of page, otherwise I should be writing it below. So now I have found out the value of one of the 3 inconnus, that is, of the 3 unknowns, one is now known, that is z is equal to 5. Now what do we do with this? Well, now that we know z is equal to 5, we know y is equal to this, so in z, in the place of z here, we can put this. So that is what we do. Remplaçant 8 en 7. So this is 8 and this is 7. So when you replace it, 7 est égal à, équation 7 est, y est égal à 23 moins 4z. This is equation 7. I put in 23 minus 4 into 5. Z we have found out is 5. So this will be 23 minus 20 and y is equal to 3. So now we have solved for the second unknown. And now remplaçant 8 et 9 en 4. So where is 4? 4 is here. X est égal à 10 moins y moins z. So if we do that, remplaçant 8 et 9 en 4, x est égal à 10 moins y moins z, d est égal à 10 moins 3, because we know y is 3, moins 5, y is z is 5, we get this, 10 moins 3 moins 5, x est égal à 2. So we have solved this system of 3 equations with 3 unknowns. We have solved using substitution, and you see it took only 1 page and a half. Okay, so now the in-video problem is, you have 2 equations with 2 unknowns, x plus 2y égale à 12, 3x plus 4y égale à 26. Résoudre utilisant les 3 méthodes. So just like I did it in 3 different ways, you have to solve this in 3 different ways. Now I also want to show you one other thing. What have I done here? Remember we started, I just recap, we started with the what is an égalité, what is an équation, then équation du premier degré avec un inconnu, we know how to solve that. Then I said you have to have 2 conditions before you can solve. The equations have to satisfy 2 conditions. One is that they have to be independent, and the other they have to be consistent. Okay. So now what this, apart from learning how to solve equations like this, you should notice how neatly and step by step I have done everything. I have numbered the equations, I have referred to, I write down at every step what I am doing. Every equation that I will use again later on, I give it a number, like number 5 here, then I can say remplaçant 5, and so on and so forth. And at no point see, for example, when I discovered here that x is equal to 2, I didn't go up here and start writing, when I discovered z is equal to 5, I didn't go up and start writing it here. I could have just written, y is equal to 43 minus 4z is equal to 23 minus 4 into 5 is equal to 3. But if I had written here after finding out z here, that means if I ever read it later on, I would suddenly get confused as to how I managed to get the value of y there. So one thing you will notice is that when I have written this, at no point I am going back up and writing something above what I have written. Whenever I write a line, that's it. I'm never going to write anything above that. If I need to copy something, if I need something from up there, I will bring it down. I will recopy it. So this way, it becomes very understandable as to what you have done, and even after a couple of years or 10 years you go back to it, you will know exactly how you did it and what you did. So I had told you earlier in the first video that I will also tell you something important. I will use these videos to teach you something important, and that is the importance of solving maths or doing maths in a systematic way, writing clearly, so that if you read what you have done after a few years, you should know what you did. You should understand what you did. For example, I give you so many problems to do as assignments. If after 2 years you go back and look at a problem and you see how you have done it, it should be done in a way that you can understand exactly how you have solved it. You should not have to think again. You should not have to solve it again. The writing should be clear enough. The development, the references, the steps should be clear enough that you don't have to solve the problem again, even if you come back to it after a few years. And finally, méthode de résolution. Here I showed you how to do elimination. Here I showed you how to do comparison. Here I showed you how to do substitution. So what do you see here? You see here that this part is a little hard to read because I've got lines written so close to each other, as compared to this where I've got a lot of white space. So realize that white space is very, very important for understanding. If this is so much more difficult to understand than this, just because there is less white space here, everything is written much tighter rather than with spaces, and this is very, very important. Not many people realize it. Indeed, some teachers say don't waste paper and don't write tightly. In my opinion, and I think this is the correct opinion, you should use white space to make things clear to you and not to become too crowded. Like this whole area is too crowded. If I had to rewrite this, I would put more space there, I would put more space there, maybe I'd have more explanations. Where I made a mistake here, I wouldn't just cut it out, maybe I'd white it out and rewrite it, things like that. So here you see how much neater it is, how much easier it is to follow, because I have used white space liberally. I've put a lot of spaces. See, all of these white space, this white space here or this white space here or this white space here actually helps you to read what's written. If it is very tight, then it becomes a little difficult to read. So here you see I don't have white space, but you know that this whole section is different from this whole section because of the white space there. This whole section is different from this whole section because of the white space there. So everything is clearly demarcated and it becomes easy to solve. So okay, this is the end of this video, and this will be the last video for solving system of equations, so solving system of equations of the first degree. I stop here. and you have to do this. This will take you a little time. You can watch the video again and follow the steps, but it is equally important that you get the answer right, but you also use white space, you write clearly, it should be legible, and please make sure you don't make a mistake, because if you make a mistake here, for example, if I say 2 into let's say minus 2y plus 3y, instead of saying y, if I had forgotten that that is minus and I thought of it as plus, then I would have put 5y here. 5y plus 4z is equal to 23. Everything from that point on would be wrong. You would get the wrong answer and all your work will be wasted. So do this slowly, make sure you haven't made a mistake, double check each step before you go on to the next one. Okay, I'll stop here now.